This product video will give you an impression about the capabilities of MoIN, prepared by 2W Systems in Flensburg, Germany. We will give you a brief overview of the MoIN use cases. After that, I will hand over the microphone to our CTO, Mr. Leif Cipriani, who will give you a live demonstration of MoIN Multimedia over IP network service software. But first, let's explain where the name of MoIN comes from. Way up in the north of Germany, MoIN is our way of greeting each other in a friendly manner. This is also the philosophy of MoIN software, connecting networks in a friendly manner. MoIN was first introduced at the IBC 2018 in Amsterdam. Since then, MoIN caught the attention from premium broadcasters. Especially the worldwide integration of AES67 in the studios and increasing number of cloud services gave MoIN a boost. So let's start our video about MoIN. MoIN is a software-based solution that fulfills various use cases in the studio, broadcasting and streaming environment. MoIN can be used on many places in the broadcast chain, such as studio to studio, studio to transmitter, web radio and many more. MoIN takes care of protocol and audio algorithm transforming and transcoding. Over 512 stereo channels are supported. MoIN software is available as server-based software, VMware and as cloud-based application. Interesting to know is that MoIN software consists of a number of software containers which can run independently to achieve a good scalability and robustness of the system. Important to mention is that MoIN is 100% 2W own developed software. With MoIN you will receive highly sophisticated software which offers professional audio quality and is extremely robust and reliable. In the studio environment, MoIN can interface with a range of standards such as AES67, Dante, Ravenna, Livewire Plus, WeetNet and EBU Tech 3326. These are just a few of the various standards which MoIN supports. MoIN can also handle all of them at the same time. Session Initiation Protocol, also known as SIP, is supported by MoIN. It takes only one click to get a SIP connection established in MoIN. Bringing up a new codec takes only 5 seconds, so MoIN is really a perfect choice in your studio and studio-to-studio environment. When your contact is ready, it must be distributed, so for that we have the use case called MoIN distribution. In the modern broadcast market, distribution means making content available in multiple protocols and algorithms. MoIN software was developed exactly for that purpose and is therefore the perfect tool to take care of distributing your content. For broadcast distribution, MoIN supports protocols such as DVB, ASI, DAB, Icecast, Shoutcast and audio over IP. At the same time, MoIN supports a range of mechanisms to improve robustness such as forward error correction, dual streaming and secure reliable transport, also known as SRT. These mechanisms allow a very robust connection over any IP network. How about internet streaming? Internet streaming is getting more and more attention from your audience and is becoming an important part of your distribution platform for bringing your content to your listeners. Icecast streaming encoders are on the market for some time, but suffer from open source software applications and shaky connections. 2W is the specialist in high-quality audio codecs and robust transport. We do not use open source software, but only professional, high-quality audio codecs. This is exactly one of the hallmarks of MoIN. Now, let's take a look at some of the use cases. This use case shows MoIN for studio on-demand codecs. The codecs are connected to MoIN, which is situated in the middle. MoIN is connected to a studio or to a head-end site. In a matter of seconds, you can connect the IP4C, audio over IP codec, to the MoIN studio software. MoIN is codec independent, so you can connect any audio over IP codec to MoIN Studio. Setting up a SIP connection network can be a hassle. MoIN Studio makes it very easy. In this application, MoIN is in the center and connects the audio over IP codecs from the regional studios and reporters via IP. The SIP implementation in MoIN and IP4C let you set up a connection by clicking just one button. This allows fast and reliable ingest and exchange of content. We have now seen several use cases where MoIN is at its best. Let's pack all of them together and look at the result as shown in this slide. In this use case, MoIN ingests content from 3 studios via IP4C audio over IP codecs. Each IP4C can transport 4 stereo channels, so a total of 12 stereo programs are connected to MoIN. In addition, studio number 4 is connected via AES67, bringing 64 channels to MoIN. MoIN transcodes these audio channels to various formats and send them in audio over IP format to the IP4C, in PCM format to the DAB multiplexer, in MPEG-TS format to the DVB multiplexer, for example for satellite distribution or DVB-T. How about internet radio streaming? As you may guess, MoIN is also the most flexible and easy to operate internet streaming encoder. The MoIN server software supports broadcast standards such as Icecast and HLS. This enables ingesting audio via AES67, Ravenna, Livewire or Dante, transcoding to an internet streaming service provider such as Wowza, transcoding to a multi-bitrate HLS stream or a single bitrate Icecast to feed a CDN directly, such as Akamai. Via HLS, the MoIN can encode the same signal multiple times in different formats. The advantage of HLS is that it streams multiple bitrates from the same radio program. Your listeners will also be connected to your radio stream, even when the mobile network has limited bandwidth. When the bandwidth goes up, the mobile phone application automatically switches to a higher bitrate. I will now hand over the microphone to our CTO and audio over IP expert, Mr. Live Cipriani. Live will show how easy it is to configure the MoIN software. Live, over to you.
All right, let us start with the MoIN for distribution by setting up a new MoIN codec container. I will set up a MoIN distribution container with the management interface connected, and I will connect to data 1 our studio interface and on data 2 our multiplex interface, so that I can receive on the studio side different audio streams and send them out as a DVB transport stream on data 2. Let's just use 4 encoders and 2 decoders. I've created the instance, and after a couple of seconds the instance comes up, declared with that yellow color here, and now we jump into that instance. As you can see, we have exactly the amount of encoders that we have set up, 4 encoders and 2 decoders, and I will start setting this up by choosing a profile for my audio that I want to transcode. And MPEG layer 2 is a good choice when we go over MPEG transport streams. I will give it a slightly higher bitrate, 384 kilobit, and I call that my MPEG-TS profile for my internal reference. As you can see, they are now all set to MPEG-TS. I could also specify another low quality profile with, let's say, 128 kilobit. And I could also use that profile. Let us receive an Icecast stream, probably a German stream called One Live, using this URL on our studio interface. And we will also receive a second stream. I will use a Danish stream for that, because we are so close to the Danish border. Also on the studio interface, connected to data 1. So by dragging and dropping them to my encoders, I have now specified that I want to encode whatever comes in on Icecast, probably MP3 as you can see from the URL, gets transcoded to MPEG layer 2, 48 kilohertz, 384 kilobit. And my other stream, the Danish radio stream, gets transcoded to the low quality profile. I just hit save. And on the overview page, I'm always able to see what is really happening. So I can see my MP3 stream gets decoded. Those are the level meters for that. And it gets encoded as an MPEG layer 2, 48 kilohertz, 384 kilobit, just as we specified it, and you can see the level meters as well. This stream looks also about right, and we can also listen into the streams. All right, both streams seems to be working. So let us set up the transport stream multiplex. I do that on the TS multiplexer page, and I can just drag and drop my audio encoders to our services. So my first service will be the one live radio program, and the provider is the West German broadcaster. And Danish radio also gets its own service, and service provider can be Danish radio. The first one is set up to be sent out on audio pit 101, and the second one is sent out on 202. I will hit save, and I need to send it somewhere. So I will send it on my studio interface, data 1, to myself. And I will send it on the default port 5004 using this interface. I will enable forward error correction and send it out. Again, the overview page always shows you what is happening. So on the TS multiplexer tab, I'm able to see this multiplexer has now 2 programs. The programs seem to be transcoded correctly. And I'm also able to see all the different service tables, the different PIDs that get sent out using the transport stream multiplex, and the resulting bitrate, of course. So to round this up, I will also receive this multiplex now using our transport stream receiver on port 5004. Also enable forward error correction. And to get the audio also through, I will have to specify the audio PIDs. 101 is my one live program, and 201 was our Danish radio program. I can also just use the transcoder here to receive it again. And you can see encoder 3 is receiving our transport stream with a quite low jitter, the amount of packets. You can really jump into the details of this transport stream. You can see all the values for the forward error correction, and of course also for the second stream, the second audio pit. And again, we can listen to that. And that's it. Next, we are going to create an instance for streaming. And we give it also 3 interfaces like we have done before. And a couple of encoders and a couple of decoders. When it comes to streaming, there are a lot of different formats you could use. Very well known are MPEG-, Icecast, as well as HLS. And today I will be showcasing you HLS and show you how to set up an HLS stream with the MoIN software. Let's go into the instance, and like always, you can use almost any of these formats to make an HLS stream out of it. And since we've already shown you Icecast as well as AES 67 streams, I will this time use a file. And HLS is an adaptive bitrate stream. So in this case, we need to have multiple encoders to encode the same audio source into different formats so that the receiving end can choose, depending on the bandwidth, what stream do I like to receive, and it can switch that during segment lengths. So every 10 seconds, for example, it could switch from high quality to medium quality to low quality, just depending on the bandwidth. That means for the end user, that the end user can still receive the service even though the bandwidth goes down. So let us specify a couple of bit rates and qualities. I will use the MPEG Layer 2 codec for this test, and I will call it HLS high quality with 384 kilobits. I will create another profile for medium quality that will have 192 kilobits, and our low quality profile with just 64 kilobits. I will use the file as our input source, and by specifying the same input source being transcoded into different qualities like high quality, medium quality, and my low quality, I will already have everything in place for our HLS stream. But the cool thing about the MoIN software is that you could now not only use that for your HLS stream, but also to create 3 different IceCast streams with different qualities, if you like. So you can reutilize the encoders, and that means you can save CPU performance because you just have to encode the audio once and make different streams out of that, like IceCast, HLS, and maybe later also MPEG-. Let's switch over to our HLS page to bundle them together to a real HLS stream. HLS means HTTP live streaming, by the way. So we give it a URL name, for example, stream, and I can also give it an internal name that we use for internal reference. And now we can choose what qualities do we want to bundle together to our adaptive bitrate stream. So I could choose just high and medium quality, or I can choose also high, medium, low quality. So we can make different HLS streams, up to 8 streams per instance, and provide that to our end user. I just enable that stream, and that's already everything we have to do to set up an HLS stream. All right, so our encoders are working, all with the different bit rates like we've set it up. And we see our HLS stream, which is working with these 3 bit rates. So the last step is maybe just to listen to that, and then we're good. I will use the VLC player for that. Open that stream. Good, so that seems fine. I could also go into details where we see the different bit rates jumping back and forth depending on the bandwidth, but this is for the more in-detail HLS setup.
Thank you for watching this video. We are looking forward to meeting you in the near future.